fascinating project in the form of a three-axis robot. So her name is Pranavi, and I'm proud of what she's done here at Bluestamp. Her ability to communicate and learn new concepts is very formidable, and her desire to want to explore and expand her engineering skills and not just stay in a pocket that she's already good at is very important. So, now, Pranavi, could you tell us more about your project?
Hello, everyone. My name is Pranavi, and I'm currently a rising senior at Mount Knox High School. So, over the past 3 weeks, I've been working on a robotics project that combines computer vision and automation. So, my project, as mentioned, is a three-axis robotic arm enhanced with a ESP32 camera module. So, the goal of the project is to have the arm detect specific objects in real time and say what it is in the frame. So, I will be playing a recording of my project as I'm currently on my PC and it doesn't have enough ports for me to have my web camera and my project on. So, unless you guys don't want to see me, I'm going to be playing my recording. So, is everyone able to see it? Okay.
Yeah, yeah, we're able to see it.
So this is my project. I'm just kind of speaking through it. This is it going front and back with the joystick. And this is the ESP32 detecting a tissue. And it detects the tissue using capturing frame one. So I'm going to stop sharing so I can explain a little bit more about my project. So you guys have all seen what it is. So now I'm going to be talking about the technical capabilities and a description of it. So the main goal of this robotic arm is to help sort recyclable materials like plastic, metal, or tissues by using vision-based object detection. So the ESP32 camera, as you guys have all seen, is mounted on the arm and capturing live video. So a computer vision model is running on the ESP32, which identifies the object, and the lightweight detection model was created using OpenCV. So this model was trained specifically to recognize two objects, a tissue and a piece of metal. So after the setup, the camera captures frames at regular intervals, and each frame is analyzed compared to the trained image data. So when an object is recognized, the system prints out the detection result on the screen. So as you guys saw, it said tissue detected. So to ensure the camera performed reliably in different lighting conditions, I also added an LED ring if you weren't able to see for constant illumination. I realized this personally after my PC, after looking at my PC and connecting it with the ESP32, I noticed how dark it was, and it wasn't able to capture the tissue or metal in real time. So I added an LED ring for consistent illumination. So the ESP32 camera communicates with the robotic arm servo, making the setup more interactive and useful in real-world recycling scenarios. So for me, the most difficult part of the project was actually the physical assembly and servo calibration. So before joining Bluestamp, I honestly did not know how to screw anything or get the joints aligned properly. So joining Bluestamp allowed me to learn more about the hardware and software aspects, such as wiring the components and ensuring all servos defaulted to a 90-degree angle without any jitter, and it took a lot of trial and error. One key takeaway I learned is how a single misalignment could throw off the entire movement path, so I had to be really precise in my assembly and code adjustments. So for example, when I was adding the servo for my robotic arm, I accidentally added it lopsided. That led for me not to be able to have the robotic arm move. So I learned how a single misalignment could really throw off the movement path. So overall, all in all, this project taught me a lot about robotics, debugging hardware, and integrating multiple systems into a single working unit. I chose this idea because I've always been interested in using tech to solve real-world environmental problems. So in high school, I was able to really delve into the computer science aspect, but I also wanted to learn the hardware aspect, which Bluestamp allowed me to do. So recycling and waste management are major challenges, and this is a small step towards automating that process. So again, I joined Bluestamp Engineering to push my limits and work on something that combined both creativity and technical skills, and this definitely delivered. Thank you for listening, and I'd be happy to answer any questions you guys have. Oh, Tracy? Oh, sorry, I thought that was a question. Jayant?
How does your camera detection system work?
Yeah, of course. So my camera detection system works by basically I uploaded not three files, sorry, two files of the tissue and metal. So it already has the system with these images, and I was able to create an OpenCV code to detect it based on physical features. So I was able to distinguish between a tissue and metal and report it in the frames. Does anyone else have any questions? Oh, Anish?
I know you said you cared about like in the environmental aspect, but is there a reason why you specifically chose like this modification for your project?
Yeah, that's a really good question. So the reason I chose the camera vision was because I've always seen it on different like competitions I've done, and I thought it was a really cool idea and integrating camera vision and using the ESP32 module. And again, environmentally conscious, that was something I wanted to add into the project because I found that's a real world issue that is something that needs to be fixed.
So does anybody have any other questions? All right, so let's give it up for Pranavi. Excellent work. Excellent work. Uh, okay, so for our next student, their project is the thermal camera, and their name is Dario. Dario, I found, was very diligent and really put forth a significant amount of effort towards this project. And he managed to take something he was relatively unfamiliar with, right? Thermal imaging technology and other endeavors that he'll uh, explain more to you about in a moment, but managed to add his own unique spin to it to really make as much use out of his time here and the products and equipment he has here. So, Dario, could you tell us more about your project?
Uh, Absolutely. So my name is Dario. I'm a rising junior at Archbishop Malloy High School, and the product that I chose was the thermal camera. And I chose this because I saw that it had a technical aspect that could build on my coding skills, and also a hardware aspect that can build on my hands-on engineering skills. And I'll give it a little presentation. Here it is, all in this tight box. You can see the screen, maybe a bit bright, but that is a live thermal view from it. I'll screen share it later to show a demonstration. But basically, the thermal camera is able to get power and process its image by being connected to a Raspberry Pi. And the Raspberry Pi and thermal camera connect using a breadboard, and the camera uses infrared to detect heat of every object in its field of view. And then the camera communicates that data to the Raspberry Pi, where the temperature values are converted to color values, which you could see, hotter things are more red, yellows, colder things are more blues and purples. Um, you can then stream the video output using a Flask website that you can access with the IP address provided once you run the code. Um, Here, I'll screen share a little example. Okay, so I'll point my hand at it. You can see it's picking up my hand temperature, and it also gives you additional information on the Flash website, such as the minimum temperature and maximum temperature, just other stuff that is pretty useful. Um, the most challenging part of this project was running and debugging code and also fitting everything into such a compact space. I had to cut many holes in the box in order to have good cable management and just for everything to fit in general. And also prior to this program, I really only knew basic Python coding, but now that I've gone through this experience, I have definitely grown and got more experience with complex code and building new electrical systems. Like another example, I've never even used a breadboard, so that was a new experience. I learned that was definitely great. And I wanted to add that just overall lesson I gained from Bluestamp was to never overwhelm myself and take everything step by step because I found that when I move at a slower pace, I make a lot less issues. And that was really helpful because for a while I was running into different problems I didn't really know what to do with. But as my instructor helped me, I eventually got through it. And I'm really glad that I went through this program. Thank you. And does anyone have any questions? Yes, did not.
How does your infrared, like I know you said it detects heat. How does it do that exactly?
So the camera has a specific sensor that uses infrared. It's basically the wavelength of light that the human eye can't see. However, this sensor can see, and it basically picks that up, and then the Raspberry Pi with the code runs it into a color scale value. Anish.
So at the beginning of your presentation, you showed like a small, what I thought was like a tablet. So is that like connected directly to your website? Like show the
Um,
heat?
so yeah, it is a small monitor. I connected to the HDMI port to the Raspberry Pi. And basically it's pretty simple. All I do is just copy and paste the IP address into the web browser and the video feed comes up like that.
Oh, okay.
Any other question? All right, so give it up for Dario. Good work, good work. Yeah, very fascinating project. Science is so interesting, and engineering, all of it. So, yeah, next up, we have another student of mine, goes by name Kwezi, and he wanted to set out an endeavor to combine his passion for cars and his desire to learn more about engineering and robotics into one project. And his project being the line following robot. I am very proud of Kwesi, the way he approached a lot of these topics. He was very earnest in talking and confronting the difficulty. It'd be all for easy for someone to run into an issue and just pretend it doesn't happen and not care about their feelings, but Kwesi did a good job communicating when he felt frustrated, when something was going wrong, but also when stuff was going well. And he was more than willing to put in the time and effort to make the project what it is now. So, Kwesi, could you tell us more about your wonderful work?
Hello, everybody, and thank you, Lee. My name is Kwesi. I go to Kip Washington Heights Middle School, and for this summer, I go to Bluestamp Engineering online. So some of so Lee told you I was building this robot car, which was really a success. As you can see, there is a modification I've built here, which is this light that lights up when it turns right. Well, actually, let me just show you. So, this light's supposed to turn, this light's supposed to light up when it turns right. But, just to prove it, I want to, find a video of this light turning right. Wait, actually, no, I'm gonna get to that later. So,
Okay.
today, my project that I was working on today was was a line sensor, was connecting the line sensor to the Arduino robot. This was, a challenge because, technically, the first time when I came to Bluestamp Engineering, I could tell you I did not understand anything, but thanks to my instructor Lee and the help of Bluestamp Engineering, well, I'm here. I now finished building my robot, which was an extreme success. Well, I had some experience of engineering when I was a little child, and yeah, just to like say that. So technically, how this robot starts to follow lines, um, it's because of this sensor right down at the bottom here. This sensor, well, these wires, they're connected to this Arduino board right here. Let me just plug something real quick. They're connected to this Arduino board right here. So technically, that will will sense the bottom line signal to follow a line. Lee, can I screen share my robot following this line?
Yes, you
Thank you.
can.
So technically, this is proof that I was able to make this robot follow a line. And as you can see here, there's actually, well, I don't actually know if you could see it, but I can. But if you could see the line, well, the dash line right here in the middle of, well, the other line. So yeah, let me just get to the video. Oh wait, this is the wrong video.
This is
Actually,
a hand phone.
yeah. Well, actually, I want to talk about that too. So technically, because of because of my wiring, I was able to make this robot just follow my hand. And yeah, let me find the actual video of that robot following. Right.
Could be either above it, or you could use the one you posted in our class chat.
Okay. Oh, I found it right here. So technically, in this video, this is the robot car following my line that I drew on a piece of paper. So let's get into it. As you can see, you saw the robot just drive right past the line because of this sensor right at the bottom right here. Thanks to this sensor, it was able to the sense the line and well the because of the code, I'll get into it in a second. Because of the code, it was able to follow the line on the piece of paper. So now let me get into the coding. So
Uh, Not to interrupt you, we're kind of running low on time, so just letting you know.
okay. So I'll just skip that part.
We can go to questions if you like.
Wait, actually, yeah. So any questions, anybody? Well, I can't like really see anybody. My
And
computer's like actually kind of buggy.
Anish has a question right now.
Oh yeah, so you said that you made a modification on your robot to have an LED when it turns. How does that work?
So technically, because of this wire right here, you see it?
Yeah, I
Yep.
see it.
So because of this wire and well, and this LED right here, if you can see,
Yeah, I can see.
it was able to, well, I put like, there were two, like one a long wire and then another one, a short wire. So I plugged it in, right, I plugged the long wire in, right, next into the, this wire right here, and then the short one out of out into GND. So technically, well, because, well, I can't really find the wire, but because of a wire, well, which was supposed it was supposed to work, but let me actually get into it. Because of that wire, when I start up the Arduino and make it be able and like when it starts to go right, it's able to light up. So yeah,
Okay, I see. Thank you very much.
you're welcome. Any more
Anybody?
questions?
No. All right. So, give it up for Quasi. All righty. Good work. Good work. Yeah. Much respect to anyone that's able to come up and talk about their project. It's not to a whole, to a whole audience. It's never the easiest thing. So I commend anyone that comes up here and does that. So, thank you for that. So for our next student, so they also worked on a three-axis robot. but they managed to put their own unique spin on it with their own endeavors to really enhance their engineering, but also create a strong foundation in mathematics and using it creatively. So his name is Jayant, and I've really been proud of his work here. His creativity when approaching his project was very immense and very useful for him furthering his endeavors, and his ability to engage with new ideas such as more abstract mathematical concepts. He was able to really want to engage them and use them proactively, which is very good. So, Jan, can you tell us more about your project?
I can. Um, My name's Jan. I'm a rising senior from Irvington High School, and I made a three-axis robotic arm, or a high torque three-axis robotic arm, controllable via joystick, using numerical interpolation for servo easing, and hardware-wise, it uses a servo breakout board and an Arduino Nano, for microcontroller purposes. Um, I also used an MG996R servo and a Muse 20 kg servo for higher torque capabilities. Let me demo it real quick. Uh, or let me show you a video rather. Um, so as you can see, there's four main joints on this robot. Let me skip a little forward because my camera direction is not very good. There's four main joints. There's the base, as was just shown. Um, let's see if I do it. Yeah, there's that. There's the shoulder. It controls the entire length of the lever. Um, or the arm, and then that's the wrist joint to control the wrist, obviously. Yeah. So, um, yeah. So essentially, how it works is that it reads my joystick input and it tells the microcontroller to send electrical impulses based on that joystick input, and it allows it those electrical impulses cause the servos to spin to a certain set degree, which is how essentially it's essentially just like a playable controller. Yeah. Let me stop screen sharing. One of my main challenges, I had many challenges when making this robot. One time my breakout board just completely short-circuited. Coding the arm was very difficult. It was very, very difficult. 3D printing is always difficult. I think in that video, I had like 50 test prints just off screen to the side. It took a really long time to do it. But I think the hardest problem to solve was the robot spazzing out, which like was like the core of my efforts throughout Bluestamp engineering. The main reason for this issue was due to the lack of torque on the arm to stop the arm's inertia when it tried to stop. So it lashed back and forth, which caused back driving on the servo motor, which made the servo think it was outside of its range of 180 degrees, which made my code attempt to reset, causing a sort of spasm of sorts. I also wanted to add higher torque for more precision. And higher torque is like indirectly related to precision. Higher torque servos tend to have better materials, which leads to less backlash within the servo. And also higher torque allows for more higher resistance to outside forces that could throw off precision. I learned a lot from Bluestamp engineering. Um, I learned that I had to plan out projects one step at a time. I would often jump to conclusions, just delete sketches out of nowhere, wasting time. I learned about the relationship between voltage, amps, and watts, which was needed to calculate um, motor power, because I could have short-circuited those motors if it gave them the wrong voltage or something. I also learned about something called numerical interpolation. In my practice presentations, I never did this, so this is a surprise to so essentially, or yeah, I never showed this image, but essentially, numerical interpolation, if you imagine 2 points, there are an infinite number of points between those 2 points, and in order to give the illusion of servo smoothness, the servo like using my code, it steps between these points, like along a curve. And because there's an infinite number of paths to get to this point, we can simulate like an infinite no an in an infinite number of types of motion, I guess. So I can simulate a bouncing motion, for example, or like um like a sinusoidal motion, that type of thing. So yeah, I also learned how to code projects on my own. I learned a lot about C++. plus plus. I learned about stall torque, which is the point at which the motor cannot rotate. Like given a load, it's like the max load that a motor can rotate, I guess. Um, yeah, and I think the main reason I joined Bluestamp was I was just really interested in creation and mechanical engineering. Um, and yeah, oh also robotics, of course. Hence I chose a mechanical arm to make, and it turned out pretty well. So yeah, thank you.
Do we have any questions? Everett?
Everett,
How much weight can the arm hold?
I'm gonna be real. I have no clue. I mean, I think it's probably maximum 20 kg probably. Um, Actually, no, it's probably around 15 kg because my arm is around the 20 kg Musée motor is 20 kg per centimeter, and my arm is around like it's pretty long. So wait, maybe it's not, maybe it's like 5 kg max actually. Yeah, 5 kg makes sense. Yeah. Oh, you have another question. Okay.
I have another question.
Yeah,
You
okay.
mentioned the interpolation. Do you know what method of interpolation you ended up using for the arm?
Yeah,
Was it
I
like
used
linear or
a
quadratic or?
quadratic interpolation type because exponential was too sudden for me, and I didn't really care about sinusoidal, so I was just like, okay, quadratic it is. Um, Andrew,
Would you say your favorite part of your project was, like favorite part of the development of your project was?
um, probably the interpolation part. I wasn't really proud of the rest, but the interpolation part I was really proud of because I mean it's a lot, you know.
Okay. Does anybody have any more questions? All right. So give it up for Jayon. Good work. Good work. Definitely a lot of effort. He didn't talk about this too much, but he did CAD and redesign pretty much his entire robot and 3D printed. So yeah, excellent work. So for our next student took what we would consider a household object and used his understanding of engineering and computer science to really add a certain air of magic to it. Pun not intended, because the name of his project is the Magic Mirror. So, his name is Sean, and what I am proud of his work in regards to his Magic Mirror is he's a very consistent and very solid at maintaining pace, right? And he came into this program knowing quite a bit about things like JavaScript and interfacing with computers, a bunch of skills like that. But he didn't use that to stagnate. He used that platform to really elevate his knowledge and skills to an even further place, which is a very important attribute to be able to have. So, Sean, could you tell us more about your magic mirror?
Yep, I can. So, hello, my name is Sean, and I'm currently a writing junior at Leonia High School. I chose my project of the Magic Mirror because it stood out to me as being a really cool concept that combined the innovation of a home automated device as well as with practicality. And so my project actually consists of a couple different things. It consists of a one-way reflective screen film that would go on this actual screen itself, as well as the screen itself, which is a 10.1-inch screen display that has touchscreen capabilities, as well as a Raspberry Pi, which you can see is screwed into the back, and the actual other microcontroller for the device itself is there as well. Now, in order to get to programs and for everything to get onto the Raspberry Pi itself, I was able to download it off of the internet and then configure it so that it would work and properly with the host computer. And I had a couple different modifications that I had in mind for adding to it, which was a motion sensor that I planned to create in order to allow it to like detect if any motion was nearby, it would turn on and off the actual display itself, as well as the bigger display, which is the 10.1-inch screen display, and a case design for the whole system using computer aided design or CAD, which is a topic I'll get into a little bit later. Now, because I haven't actually developed the case in its entirety yet, I will show a demonstration of a video of the actual display or magic mirror itself in progress and actually working. So here is the actual magic mirror itself. You can see it displays a bunch of different information such as time, the date, weather forecast, other sorts of information. And then in the bottom right, there's a breadboard and the actual motion sensor, which you can see I will demonstrate how it actually works. You'll see in the top, there's a timer that's counting down, which is kind of just the interval as if it doesn't detect any motion within that time period, which is in this case 2 minutes, it will shut off. But as you can see, when I move my hand and move my arm, it reset. And then there's also a couple different accessibility options, such as dimming it and turning it on and off. And there's also a way to actually turn the whole display off itself via touchscreen, via actually touching the device itself. Now, I this was a really good project because it actually helped me improve in my skills in programming as well as designing and stuff like that. I was able to think in different innovative ways as well as my computer aided design process for creating my case. And I'll actually here I can show a little example of my actual prototype for the case that I'm designing for the whole system itself, as it's not completed, but it is in progress. I'll show that here. So CAD or computer-aided design is a technology that's used in a variety of different fields of engineering. It's really useful because it allows people to create their own models and design prototypes for all sorts of things and even use them in the real world, such as like 3D printing and stuff like that. As you can see, here's the actual case itself. It has a bunch of holes for the ports of the different devices, such as the Raspberry Pi and the actual embedded system connected to the device. And I plan to finish this and actually implement it and be able to apply it to the device itself and allow for so that it can protect the whole entire system itself. Now, there were a couple issues that I did run into when trying to uh, when trying to make my project, which included the installation process. There was some issues with actually installing the operating system onto the device itself, as there were incompatibility issues with the Node.js environment, which is kind of just the program that is used to run JavaScript. And because this project is mainly based on JavaScript, that was a very vital, important detail that I need to fix. But that was it wasn't too hard to actually troubleshoot and manage to get workaround as I was able to quickly resolve that one. There's also a couple
Sean, it's
incompatibility.
around 4 minutes. It's been 4 minutes, so just so you know.
There's also a little bit of compatibility issues with each module or each customizable aspect of it, but I was able to easily get through and work through all those. Um, like I said, I was able to gain a lot of experience with programming in Bash and JavaScript, and thank you for listening, and I'll be happy to answer any questions. Yes, Andrew.
What OS did you use for the microcontroller?
So I used a Raspbian OS, which is like a Linux-based Raspberry Pi operating system. And also the Magic Mirror OS itself is based off of JavaScript and also some uh, C code that is actually like the whole entire workspace that's actually used for the device. So yeah.
Got it. Thank you.
Mm-hmm. Yeah, Anish.
What would you say was your favorite part of building the whole project?
I'd say probably the being able to customize and like the actual customizations as modification stage where I was able to plan out and think of all the different possibilities that I could use for creating modifications. I think such as like the motion sensor and the touchscreen and bigger display.
Okay, thank you.
Hmm.
Does anybody have any other questions? All right. Good work. Give it up for Sean. Wonderful. So, does everyone know? We have around 17 minutes left. So just so people aware. So for my next student, their project is also an endeavor in the field of robotics and computer science. They managed to take a robot and manage to have it follow a red ball, which he can explain more about the mechanics of that in detail. Name of the project, Ball Tracking Robot. Wow. And the student's name, also Ball Tracking Robot. Wait, no, Andrew, yeah. Um, so yeah, Andrew, I'm really proud of the way they really put himself towards this project, right? He's very patient the way they works, and he exhibited great attention to detail. He exhibited a lot of the measure twice, cut once mentality, which is very important for making a quality engineer. So, Andrew, could you tell us more information?
Yes, sir. My name is Andrew S. I'm a rising senior at Klein High School, and as Mr. Nestor said, my project is a ball tracking robot. So the way the project works is that as the name suggests, it tracks a ball. And let me give you a hands-on demonstration of how this works. Lee, may I share my screen so that they can get like a see the code
Yes,
and
you
look
can.
about
Yep.
it? All right. Everyone see?
Yep, we can see.
As you see, it searches the surrounding area for the ball, and then once it sees the ball, it'll go towards it. Can you guys see?
Yep, coming across well.
I don't know if that was a proper demonstration. So the way it works is that now the way this robot works is that it has mainly four core components. Now, number one, we have these sensors. Now, what these sensors do is they send ultrasonic waves out onto the surrounding area to make sure it doesn't hit any objects while it's searching for the robot. You saw how it was spinning around so that it wouldn't collide with the ottoman there? That was the sensors in action. The second part is the PyCam. The PyCam uses an app called Computer Vision, which lets it switch around and it highlights the ball. It highlights the red ball in a green outline, and that way it'll know it's the ball. So that way it knows to go towards the ball. Now, how does it go towards the ball? Well, it uses a circuit called a motor controller. So what a motor controller does is it's a device that gets electronic energy from a power source, and then it sends a signal from that power source to the wheels of the robot, as you'll see back here, called motors, and they'll convert those motors to send a signal to turn into mechanical motion. Essentially, a motor controller converts electrical energy into mechanical motion. All three of these parts are powered by the Raspberry Pi. The Raspberry Pi is the power hub of the power hub of the robot. And it's where the program that, as you see, I developed. It's where you guys can see, right? It's the program I developed. It's
On
where
the screen right now.
hmm?
You're not sharing your screen right now.
It's where the program that I developed, um, it's where all the code goes into. So the reason why I joined Bluestamp Engineering is because kind of like I wanted to explore the integration between hardware and software. To explore the integration between hardware and software. And I did face a lot of issues with the project, mainly because I was new to wiring. So, and just the electrical engineering part of the robot, the electrical engineering in general. But with the help of, just a shout out to, but Devin, actually, who had done the project before, and Mr. Nestor, they had some experience and they were able to help me get through any issues that I had with the bot, which I really appreciate. And yeah, so that's my bot tracking robot. Any questions?
Nisha has a question.
Yes. So, you said that the Pi camera is able to highlight the ball. After it highlights the ball, how does it actually go and like track it
Sorry,
after that?
I could have been more clear about that. So what it does is, so it has some commands. Let me show you. It has commands essentially: reverse, forward, stop, left, right, sharp left, sharp right, and essentially it'll run those commands to like gradually turn left and right. It just gradually turn around until it sees the ball. Once it sees the ball, it sends a signal back to the robot to run a command that heads straight towards that ball. Does that make sense?
Yes, that made a lot of sense. Thank you.
No problem.
Anybody have any other questions? All right, so give it for Andrew. Good work. Good work. So yeah, got around 11 minutes left. So just letting people know. So for our next student, they also are environmentally conscious, but in a different way. They had a desire to learn more about their weather, not only the weather, but also microcontrollers. So what better way to combine them than with their project, the ESP32 weather station. So the name of the student, Anish. I'm very proud of Anish. He managed to demonstrate a solid understanding of his work, and he has a very good ability to intuit concepts and new ideas, and then come up with ways to like use them proactively, which is very helpful. So, Anish, could you tell us more about your project?
Yes, absolutely. So, hello everyone. My name is Anish. I'm a rising 11th grader at Lynbrook High School, and my project is an ESP32 weather station, which I've also added an additional functionality to have a CO2 sensor. So now a demonstration. Currently my project is plugged in, and you can see here there's a display. It's a little bit hard to read due to like the frame rate on the camera, but it gives a city, the country of the city, and also temperature, pressure, humidity, and wind speed. In the last row, it gives CO2 data. And then over here, there's a light which signals the air quality. Additionally, with the CO2 data, all of it is uploaded to a site called ThingSpeak, which is useful because it's able to visualize it through things such as graphs. So as you can see here, it's able to graph some of the data. And so as for the overall way the project works, the project is made up of an ESP32, and this is kind of the brains of the project. And this is very useful because it connects to the Wi-Fi, and this then allows the ESP32 to connect to the internet. And this is very important because the ESP32 gets all its weather data for the city from a site called Open Weather Map. And so it just pulls it from the site, and then it also puts it on the display that I showed. That was the base project. As for the modifications that I made, I added a CO2 sensor, and the ESP is able to put this data on the display module as I showed, and also on ThingSpeak. Additionally, I added the LED, which is an RGB LED, and it shows green, yellow, and red for different air qualities. The most challenging aspect of this project was working with the ESP32 and with C++ since I was not very familiar with them and the way that they work. And so this led to some major issues along the way, which required a lot of testing, experimenting, and debugging to get around. Overall, I picked this project because I thought it had a nice mix of both hardware and software, as well as a nice real-life application since it was a weather station. While doing it, I was able to learn a lot about C++ and also about the concept of Internet of Things, as there was a lot of data fetching and uploading throughout the process. I also learned more about the ESP32 and about how certain electrical systems work, like an analog to digital converter or pulse width modulation. I also learned about the power of math encoding, as there I have one single equation that's able to calibrate the sensor for use with carbon dioxide, because otherwise it's just a standard gas sensor. And I also was able to learn about how to integrate different programs together for a smooth end result. Overall, I joined Bluestamp Engineering because I thought it would be a guided way to make an engineering project and due to my passion for engineering. And also, I thought it would be a good way to try something new that I really had little to no experience with. It also taught me how to make modifications, which is I thought was very valuable due to the quick thinking it requires and also the integration thinking it also requires. So that was the end of my presentation. I can hear any questions. Yes, Jayon.
How does the the carbon dioxide sensor work?
So the carbon dioxide sensor, it has a metal, which I believe is called tin oxide. And what this metal does is that when it comes into contact with the several particulate matters that it can react to, what it does is that if they're in greater concentration, the conductivity of this metal increases. And so what this does is that it lets more current flow to the output pin of the sensor, and thus that gives a reading, which you can then use for different air qualities. I see Swati Rao.
Really cool project. I was wondering if you wanted to build on this after the program ended, do you have any ideas for what more you could add?
I think if I had to build on it, I would add something maybe more related to machine learning or something like that to be able to predict carbon dioxide patterns throughout the day in the future, or even like weather patterns in the city in the future.
Thank you. That's very cool.
Thank you.
Does anybody have any other questions? All right, so give her a niche. Give it up for a niche. Wonderful work. Wonderful work. So for our next student, last but not least, their project came in as more of a computer science endeavor where they managed to learn about machine learning. But then they managed to expand that about learning about machines and tying that with their already existing knowledge of robotics. With their base project being posed estimation, the student's name is Devin. So I'm pretty proud of Devin and his work. He exhibited great interest in his project, being able to explore it in a whole various different categories. He also put in significant effort to support and help his classmates with his previous Bluestamp and just general engineering experience, which is very admirable. So, Devin, could you take us away?
Thank you, Lee. Hello, my name is Devin. I'm a rising junior at Marine Academy, and my project was the pose estimation with Raspberry Pi. So the way that the baseline project works is it's an open source TensorFlow machine learning model named PoseNet, and it guesses your pose based on its threshold of certainty. Once it passes that threshold of certainty, it returns an outline of your pose and numbers your joints. So my first milestone was setting this up, and I had some errors compiling the library OpenCV, stands for Open Computer Vision. But I just wiped my Pi and started from scratch, and it fixed it. So next, I wanted to add a physical element to this project, and I saw that when you return the joints, it could also return coordinates. So I found this mathematical function which would get the coordinates from the joints, then find the difference between the x and y values of these coordinates. Then it would apply the inverse tangent function, and then convert from which would be radians 2 degrees to get the segment angle, which is needed, which I then sent to an ESP32 to write onto servo motors, which were connected to a robotic arm. The arm I had a ESP32 and an arm from past projects I've done. But in the arm I had, by some like stroke of luck, it like worked perfectly for this. I didn't need some super complex mapping, but I wanted a arm which with more range of motion. So when I did get that new arm, it was like it would not work if I used the same approach. So I had to map the angles because the mathematical function would return angles between -180 to +180, so a full 360, but a servo can only go from 0 to 180. So in the end, I just needed to half the values and add 90 or 180, depending on if it was left or right. Um, so I kind of overcomplicated it a bit, but then I eventually managed to get it working. And here is, oops, let's see. I'm gonna try to show you both the Flash Extreme because I set that up too. And okay, so oops. All right, so
The screen is black for me.
yes. Do you see my phone?
Yes.
All right, perfect. So um here's the wooden chassis I said I attached it to in the end. Here is the Flash website, which shows my pose. So here we have the arms. Um, I made my arm, it tracks pretty well. The left arm definitely works better than my right arm. Um, so we have when putting it, attaching it to this wooden chassis, I had some trouble. I definitely broke a pie cam, so I had to switch it to a webcam. So that's why you see two webcams on top of that monitor. The right arm doesn't track as well, so in the future I would like to change that. But I stuck all the elements into this axis. And it's all working. So oops, sorry for the noises, that's just the servos. So I got it. 1 second. All right. So my goal for this Bluestamp engineering session was to have a more code-focused project, and that's what I did until essentially I changed it completely and did kind of 180. But that is what I accomplished. And then my takeaway is that for approaching problems from different angles, I sometimes it's just best to like put it on paper, pen and paper. Like this is something I worked out about the mapping function, but it was like way too simple for me to be overcomplicating it, and I just overcomplicated it, and that was just got me stuck on it for a couple of days. So that was a bit unfortunate, but thank you so much for listening.
So, does anybody have any questions? Andrew?
You mentioned how you overcomplicated the process. Could you explain this more how you did that and how it hindered you?
Yeah, so I did this weird thing where I tried to find point I tried to graph it. I tried to graph which points would be for where my actual arm would be and where the servo would have to write to. So I tried to graph it and then I tried to find some function, some like mathematical like line which would connect to all those points. And I couldn't find one because it didn't exist because it did exist actually. It was just y equals x plus 90. But I was looking for I was looking for a like a parabolic line when it was really just linear because I was looking at I was looking at two arms at once and that didn't make sense because it was like a sideways N.
Does anybody have any other questions? All right, so give it up for Devin. All right. Yeah, good work, Devin. And then now, give it up for everybody here who presented tonight. Definitely wonderful process, right? It's a very difficult, especially for us engineers, to want to go up and present in front of an audience. But every student here who managed to do that today should feel good about themselves because it's a difficult thing to put yourself out there. But I know that they grew from the experience. So definitely solid work, everybody. Solid work. So we went a few minutes over, so my apologies. So now I would say we should head into the main room.
Yeah. I'm going to go ahead and stop the recording now.